Hello class, this is the video for section 4.9 and talks about antiderivatives. And in this video, this will be our learning objectives, two of them. Find the antiderivatives of functions. In other words, we are going the opposite of what derivatives that we did so far in this class. Apply this concept to rectilinear motions. In other words, finding particles or objects moving in a straight line, assume with that assumption. All right, so where do we have these antiderivatives? It's very important. In a physicist who knows the velocity of a particle might wish to know its position, okay, at a given time. Well, can we apply again in engineering? An engineer who can measure the variable rate at which water is leaking from a tank wants to know the amount leaked over a certain period of time. Or a biologist who knows the rate at which a bacteria population is increasing, okay, or a virus, in this case like COVID-19, might want to deduce that the size of the population will be at some future time. Okay, so that's why they are predicting that 100 and something million people or to be, cases and so on with this COVID-19. All right, so in each case, as we mentioned above, the problem is to find a function f, capital F, whose derivative is a known function f. Okay, such is what we call the antiderivative. So the capital, if it exists, that capital F is what we call the antiderivative. So here's the definition that a function f is called the antiderivative of a function f, small f, on an interval I, if the derivative of the capital F is equal to the function f, the small. Okay, that is the antiderivative of f is the function whose derivative is the function of f. Okay, so the following theorem says that if f, small f, has no other antiderivative, then this theorem is true. And that is called that if the capital F is an antiderivative of a small function f on an interval, then what we call the most general antiderivative of the small f on the interval is given by our capital F plus c. And then where c is a constant. Now, we'll note that we'll be able to find the value of the c, the constant. Okay, so here is what happens. For example, if you have a function f of x, which is s squared. So if you want to find the capital F, right, of the function, in other words, we want to find a function, when we differentiate it, we get x squared. Now you notice that if we do this plus 1 and divided by the same exponent, okay, this will give us x cubed divided by divided by 3. So let us test if this is true. Let's find the capital F of x, okay, which will give us 3 times 3 minus 1, which is 2, divided by the 3, which was already there. And this 3 will cancel out, so that gives me s squared. Okay, so the function capital F, as we see, the antiderivative of the given function is 1/3 s cubed, all right, plus a certain constant. Now, that constant could be 1, okay, because if you differentiate a constant, you get 0. So if this case plus 1 is it's going to be 0, and that gives me s squared. Or the constant could be 2. If we differentiate this function, the capital F as it is, the constant will also be 0. And so if the the constant is 0, this is the graph in the red. Okay, and if it is plus 1, that means we moved it up by 1 unit. Plus 2, plus 3, or minus 1, minus 2. So all these functions, okay, in this graph, as we can see, are antiderivatives of okay, the s squared. That is why when we find the antiderivative of the function, okay, of the function, we got 1/3 s cubed. We always add a constant, which the c could be determined. Okay, so let's use this approach and find the antiderivative of the following. We are given A, part A, f of x is equal to 1 over x. Okay, there's a function, okay? Now remember, there's a function that when you differentiate it, you get what? 1 over x. Assuming that I want to use the approach I use for the x squared, right? I'm going to write this as what? Minus 1. So let's try to differentiate this. Okay, using that approach. So if this is true, my capital F of x, my antiderivative of the small f will be what? X raised to minus 1 plus 1, because we add 1 divided by minus 1 plus 1. Now guess what? This gives me x equal to 0 over 0, which is undefined. Okay, so you cannot write this, the exponent, the approach that I use, which we'll see in the part C, the n, the exponent cannot be what? Negative 1. It could be any other apart from negative 1. Okay, so this approach will not work. Therefore, what is the capital F of x, the antiderivative of what? 1 over x? Well, if you remember, when we have a function, if y is equal to natural log of x, then what is the f prime? It is what? 1 over x. So it means that the antiderivative of 1 over x will be what? Natural log of x plus what? Plus c. And that's what we call what? The general antiderivative. Okay, for g of x equal to x, so if I find the capital g of x, that's the antiderivative of that is going to be x, because the exponent is 1, so that'll be 1 plus 1 over 1 plus 1, then plus what? The constant. So this is what? 1/2 x squared plus what? Plus c. So my antiderivative, if I want, this is the same as the capital F of x, okay? Okay, so generally, if I want to use what I use in part C, and then also for x equal to f of x equal to x squared, this is the formula that we just use. So the antiderivative of this function in part C was what? X, when n is not equal to 1, is n plus 1 over the same exponent, n plus 1 plus a constant was c. This is what we call the what? The power rule. Okay, it's called the power rule. Okay, let's go to part D. What is the antiderivative of sine of x? That is, when I differentiate that function, I get sine of x. Okay, let's try this here. So you have what? Capital F of x is equal to, well, if you differentiate sine, there's a function that you differentiate sine, you get, if we say this is what? Cosine of what? X. Okay, if you differentiate cosine, you get negative of x. So we got to put what? Negative in front of this. All right, plus c. Well, let's test if that is true. The derivative of this is what? Minus, if I differentiate cosine, I get what? Negative sine. Then if I differentiate the constant, I get what? 0. So negative gives me what? Sine what? Sine x. Okay, so therefore the antiderivative of sine x is what? Negative cosine x. That's a general most general antiderivative of that. Okay, now like I said, these constants could be determined. Okay, this is valid. All that we have said, that is for part C, is valid for n greater than or equal to 0, since this is that f of x is equal to x of n. It's defined on an interval. If n is negative, that is negative 1, it is valid on any interval that doesn't contain what? 0. Okay, so if it's negative, it will work as an integer, but not for, or a real number, but not negative 1. Now, the following gives us a table for the function and its antiderivative. All right. So here is, so if you have a function c times f of x, that's going to be c times small c, which is a constant, times the capital F of x. That's the antiderivative. Okay, like the one we did, sine of x, the antiderivative was negative sine. Secant squared, the antiderivative is what? Tangent, because if I differentiate tangent, I get what? Secant squared. And then secant tangent is what? Secant. So all these, if you have this, that is what? Arctangent of what? X. If you differentiate, I get 1 over 1 plus s squared. Okay, so the arcsine, and then the e, if you antiderivative of e is what? Is e of x. The antiderivative of 1 over x is what? is natural log of absolute value of that, because we want to make sure that the x is not negative. Okay, then if you have the exponential function b to the x, that is what it is, b to the x over what, natural log of that. Now let me pick that. Suppose that my small f of x is equal to, say, 2 to the x. Now what's the antiderivative of this? Okay, the antiderivative of 2 to the x divided by natural log of what, 2. So let's differentiate what, after capital f of x, that's antiderivative of that. This is equal to, if you differentiate, remember we have 1 over natural log of 2 already there. If you differentiate 2 to the 2 of x, 2 to the x, you get 2 to the x times natural log of what, the base. And then this will cancel out. Well, plus, this is going to be plus c, for that to be plus 0. And the answer will be what, 2 to the what, x. And so take note of this table and know these formulas, because it's going to be helpful. All right, now let's go to some examples. Apply this. Now, I want to find the most general antiderivative of f of x. It's exercise number 2. Okay, so my capital f of x, if I find the functions whose derivative s squared will be what? 1 over 3 x to the third, because you get 2 plus 1 over 3. The minus, I get 3 x to the what? 2 divided by 2, then plus what? 2 of x, then plus c. Okay, if I differentiate 2x, I get 2. If I differentiate this, I get that. All right, now let's simplify that. That's it. This is going to be what? This is equal to just 1/3 x cubed minus 3 over 2 x x squared plus what? 2x plus c. Okay, let's go to number 17. Okay, my capital h of theta, that is antiderivative of the function given. Okay, remember, if you differentiate sine, you get what? If you differentiate a function that when you differentiate, you get sine, is what? Negative cosine. So the antiderivative of the first term is what? 2 times minus cosine what? Theta. Okay, if I differentiate tangent, I get what? Secant squared. So the antiderivative of secant squared is what? Tangent of what? Theta. Plus what? Plus a constant. So the answer will be what? Minus 2 cosine of theta minus tan of theta plus what? Plus c. And that is my what? The antiderivative of the function what? Given. Okay? So here is the answer for that. Okay, let's take other examples. Okay, like we said, okay, these constants, the c, or if you use a d, whatever it is, could be determined. Okay, the constant what? The constant c can be what? Determined. Okay, well, we have what we call the initial value what? Problems. Okay, if you have heard about differential equations, that's where differential equations comes from. In fact, differential equations is a whole class of its own. Okay, you can take differential for order 1 and 2, and so that if you want to know about this, but it is stemming from what? Initial value problems, because if I give initial conditions, then I can find the value of c. We'll look at examples in a minute. Okay, an equation that involves the derivatives of a function is called differential equation. It involves the derivative of a function. It's a differential equation. So the general solution of a differential equation involves an arbitrary or constant or constants. However, there may be some extra conditions given that would determine the constants, and therefore uniquely what specify the solution. Okay, so here is an example. Now remember, if you are given the f prime prime, right? The antiderivative of f prime prime is f prime. Okay, so the Derivative of what? F prime. Prime is what? F prime. And then also the antiderivative of what? F prime is what? Is F. So we're going to do two steps. First, let's find the what? F prime, which is the antiderivative of what the function given. This is what? 20x to the what? 3 plus 1 over 3 plus 1. Then minus 12x to what? 2 plus 1 divided by 2 plus 1. Then plus 6x 2 divided by 2. Then plus a constant c. All right, so if you do this, you have what? 20x to the 4 divided by 4 minus 12x cubed divided by 3 plus what? 6x squared divided by 2 plus what? C. Now, if you simplify, that gives me 5x to the 4 minus 4x third plus what? 3x squared plus C. So now we want to find F, which is the antiderivative of what? F prime. Okay, so then F, the function F, okay, is equal to the antiderivative of F prime. So we find the antiderivative of this, which will give us what? 5 x to the 5 over what? 5 minus 4 x to the 4 over 4 plus what? 3x cubed over what? 3 plus c times x, then plus another constant d. Okay, so if you simplify this, you have what? The 5s will cancel. So you get x to the 5 minus x to the 4 plus x cubed plus what? Cx plus what? Plus d. Okay, so this is my f of x. Okay, so because we give us what? Two, it said find the general what? What do you call it? Most general what? Antiderivative, and that's the answer. Okay, here is another example. Okay, now here they've given us what? This is what I call the initial what? Conditions. They call them initial. Okay, initial conditions. Okay, we are given the f prime at 0 is equal to 4 and f of 0 is equal to 4. So to get the most general, it has to be f of x. So each of them will help us to find one of the constants. All right, so let's get going. Now, first, the antiderivative of what? F prime prime is what? F prime. So let's find f prime of this. Now, what is that? That is minus cosine of theta. Oh, sorry, this is theta, not x. And then plus what? Sine theta. Because if I differentiate sine, I get cosine. If I differentiate negative cosine, I get positive for sine theta. Plus what? Plus a constant c. But we are given that f prime of 0 is equal to what? 4. Meaning when theta equal to 0, okay, then f of 4, the function f prime of theta is equal to what? Is equal to 4. Excuse me. So let's set this to 4. That is minus cosine of 4 theta, theta is 0, plus sine of 0 plus c, where we get 4 is equal to minus cosine of 0 is what? 1. So that gives minus 1 cosine. Sine of 0 is 0 plus c. All right, so that means that my c is equal to 4 plus 1, which is 5. Therefore, my f prime of theta is equal to minus cosine theta plus sine theta plus what? Plus 5. So see that we determine the value of what? So this will give me a particular solution to that. Well, let's go again. Since f is the antiderivative of what? F prime. So we find this is equal to the antiderivative of this expression here, all right? Which is minus, if I differentiate a function, I get negative sign. That should be what? Negative cosine. That should be what? Negative of what? Negative of what? Sine. Then to get positive sign, it has to be what? Minus cosine what? Theta. Then I have 5 times what? Sine theta plus another constant d. Okay, but we are given this initial condition that theta equal to 0, f is equal to what? 3. That means, okay, we have 3 is equal to minus sine 0 minus cosine of 0 plus 5 times 0 plus what? D. And then this gives us what? 0 minus 1 plus 0 plus what? Plus D equal to what? 3. And what is the value of D? This will be equal to the before. Therefore, f of theta is what? Minus sine theta minus cosine theta plus 5 theta plus what? 4. This is what we would call the most what? Most general antiderivative. Okay. So as we can see, assuming this is acceleration is what? Second derivative, right? And so the first derivative will be the velocity, and the f will be the what? The position function. So we can apply this to what we call the rectilinear what? Motions, and that's where we're going to. Now, what is rectilinear motion? Okay. Now, anti-differentiation is particularly useful in analyzing the motion of an object moving in a what? In a straight line. Okay. We know if the object has position function s, which is a function of t, then the velocity is a derivative of that. Okay. The velocity is a derivative of what? The position function. That means that the position function, all right, is the antiderivative of the velocity. So we are going backwards, right? Likewise, the acceleration function is giving us what? A of t equal to the v prime. If we differentiate the velocity, because the rate of change in velocity is what? Acceleration. So the velocity function is an antiderivative of what? The acceleration function. So if the acceleration and the initial values s of 0, v of are known, then the positive function can be what? Can be determined, okay, by and find the antidifferentiation what? Twice. Okay, in a summary, this is what is happening. Okay, we know that if you have what? The position vector s of t, and if you want to get a velocity, and then if you want to get acceleration, okay, if you have the position vector s of t, okay, if you are going this route, if you're going this way, what is that? If you're going this way, this is what? Differentiation. That's differentiation. All right. So, but if you have the other way, you have what? We're going backwards. You have what? A of t, and you want to get what? The velocity. And if you want to get the position what? Vector or function. And if you're going backwards, is what? Anti-what? Anti-differentiation. Okay, it's anti-differentiation. So if you have the acceleration function, if the antiderivative of that gives you the velocity function, if you find the antiderivative of what? The velocity function, you get what? As the position function. This is what for the previous example, this is your what? F prime prime. This is your F, and that is your F prime, that is your F, okay? And then over here, this is my F, this is F prime, this is my F prime prime. Good. Now let's apply this to one problem. It said a particle moves in a straight line and has acceleration given by what? A of t equal to 60 plus what? Plus 4. With its initial velocity, that, and then initial displacement, which is the position what? Function, s of 0 is equal to 3. Find its what? Position function s of t. Okay, so here we are given s of 4t as what? 60 plus what? Plus 4. Okay, so for me to find the velocity, I need to find the antiderivative, v of t. The antiderivative of this would be what? 6t squared over what? 2 plus what? 4t plus a constant c. Now this gives me 3t squared plus what? 4t plus c. This is 4. Okay, but we are given the condition. It says that v of what? 0 is equal to -3. Sorry, -2. So that means that's -2 is equal to, when t is equal to what? 0, plus 4 times 0 plus c. That is what? C is equal to -2. Okay, so then that is what? The velocity at time t is given by what? 3t squared plus what? 4t minus 2. Now, the position, all right, the position what? Function s of t, okay, is given by, is the antiderivative of the velocity function. So s of t, we find the antiderivative of that will be 3t to the third divided by 3 plus 4t squared over what? Over 2 minus 2t plus a constant. With, let's call it, say, d or c1 or whatever. Okay, it's a constant. So, but we are given this initial condition. This is equal to what? Is equal to 3, which means, right, we have what? 3 is when time is what? 0. That gives us, this will be 3. Actually, this would just be what? 0 cubed plus what? 2, 0 squared minus 2 times 0 plus what? Plus d. Okay. Now, if everything is 0, means that your d is equal to 3. Therefore, the position what? Function s of t is equal to what? T cubed plus what? 2t squared minus 2t plus what? Plus 3. And that is the end of what? Of the solution to the problem. And that's the end of this section. We'll take more examples in class. Thank you and see you soon. Bye.